Hello everybody, today I'm going to discuss the solution for the second problem from the 2025 USACO February contest in the Silver Division, the problem vocabulary quiz. In this problem, we are given a sequence of words and we know for each word the word from which it originates, plus the fact that that word will have one extra character. And in this problem, we are also given the fact that for each word which is not a prefix of another word, we are going to have Elsie try to answer quickly to the question of how many times she has to, how many seconds she has to wait until she can identify the word according to the problem statement, because basically Bessie tells Elsie words and Elsie will have to mention the answers as she finds them. And now obviously, depending on the order in which she gets to know the words, she can figure them out faster or slower, because whenever she has already heard some words, she can make deductions in order to get the answer to be even smaller. And now, obviously, we're given here a bunch of inputs and the way to answer to some of these queries. So obviously here for 2, 3, and 4, we know that for 4, because it's the first word, she would have to hear it all. Then as we keep going, we would have a situation in which if there are fewer letters which have to be read, she would identify very fast the words. Now, obviously, the first question that comes into our minds is, how do we even model this kind of structure we are given in the input, with the words being formed by taking a previous word and adding a single character? And if we think a bit about this sort of structure, this is actually very reminiscent of a tree, because basically it tells us that when we know that we have to construct a word based on, let's say, the third word and add one more letter, it's the same thing as having an edge between 3 and that respective index. So, for example, if we look at the second sample, we have the root at node 0. So we would have 0, then 1 and 2, and according to the statement, 3 and 4 originate from 1. So we have now a tree structure. And the words which don't have any, which are not prefix of any other word, are the leaves. And now the question is, how do we find for a leaf how much Elsie has to wait until she can uniquely identify that this is the current word? And if we think a bit about this sort of idea, obviously this can be done in a lot of very advanced ways, using a lot of data structures at various levels, gold, platinum, and so on. But actually, it turns out that we can start from some simple observations and work our way towards finding the answer. And let's start even with this node here. This node, because it has 2 leaves right next to it, obviously when we have when it's the first time we reach one of the leaves, we will have to wait. We will have to at least go up to here in order to uniquely identify the word in question. So because of this reason, if a node has multiple leaves in its subtree, as long as the word mentioned is not the last one, then for all of the other words, we can confidently say that she will have to speak at least until she can make this separation, this separate branch, because for all of these she will have to mention 1. But in order to deduce the 3 from 4, at first you will have to say either 3 or 4. So this gives us the motivation of thinking at some sort of algorithm which takes the leaves and the positions they belong to in the query. And in a way, it's kind of like having a very simple subtree maximum idea where, for example, here, because this word shows up before this one, she will have to wait 2 steps until saying it. But then for this last one, we transferred its position to the next node. And then when we go to these 2 nodes, obviously, in order to get to 0, she will have to say 2 first. So this will require 1 move, for example. And then for this tree, which goes until the very end, she will have to go until the beginning, and this third leaf is gonna have actually answer of 0, which, as you see in this example, it's also very consistent with what we have to do. Here the order is slightly different, so 4 was actually 3 in this drawing, and as you see for 4 we had to use 2 moves, and then 1, and then 0. Now, in order to compute quickly these answers, I actually stored a bunch of information in this tree, and I ran a DFS algorithm in order to quickly deduce the answers, as I'm going to show you now in my code. And basically, I started with doing a DFS to see how many leaves I had, because this was also part of the task in order to identify the numbers on which I have to perform these queries. Then I did another DFS starting from the root, in which I kept track of the current level of the node. And if the current node is a leaf, then I marked it as being the leaf corresponding to that vertex. Otherwise, for every query, I took the position in which it is, I sorted them, and then for all queries which are not the last one, we know that we must speak at least until the position, the next position after the current node, in order to be able to separate them, just like I showed earlier in the drawing. And then for the last query, we will have to perform the answer, like I mentioned, and keep going upwards as we process this node from the perspective of something above it. And I think that the most important thing to be careful about when it comes to a problem like this is to try to reduce it to a problem which has a more familiar structure. Like, for example, the input and the way they were mentioning the prefixes and the extra characters and all that stuff doesn't give much of a clue. But when you think a bit deeper at it and you see that we can actually end up reducing it to some sort of a tree structure, things become much easier and much more standard, which is something that happens a lot these days in USACO, and is something that you will have to be very careful about when you solve problems both in contests as well as when you practice. And after doing that, you must have observed that we didn't have any trouble with arriving to a DFS-like algorithm, which takes some minimums and some maximums, maybe with even a bit of sorting to reach an n-log algorithm. If you like the video, please like it, subscribe to the channel, and press the bell button in order to stay tuned whenever I have any new video, be it for USACO or for other competitive programming contests. In addition, I want you to also check my other videos I made on Bronze Division as well as on the other problems in the Silver Division. In addition, if you have any suggestion, feedback, or remarks you would like to mention, I would love to hear them in the comments, because I reply to every single one of them and I want to make sure that everything is clear from your perspectives. And if you have any relevant suggestions, I would be delighted to apply them in my other videos. Last but not least, if you or someone you know is interested in working more closely with me, I recommend checking my website in the description for ways to join my tutoring program. Until the next time, I wish you the best of luck for the remaining USACO contests, and we'll see each other next time. Cheers!